Continuing in section 2.9, the cost in dollars to produce Q gift baskets is given by C of Q. So capital C stands for cost at a quantity of Q gift baskets. So C of Q is equal to 160 plus 2Q plus 0.1 Q squared. And we want to find the quantity where the average cost is a minimum. Now, first of all, what is the average cost? The average cost is equal to the cost divided by the quantity. It's like there's a total cost divided by the quantity of baskets. And in this case, that's just going to equal, and I'm really just copying from here. That's going to equal, the cost, which is 160 plus 2Q plus 0.1 Q squared, squared, divided by Q. And so C is equal to 160 over Q plus 2 plus Q plus plus 2 and plus 0.1 Q. 0.1 Q. And that's because 160 divided by Q is 160 over Q. 2Q, I see what I did there. 2Q divided by Q is just 2, and 0.1 Q squared divided by Q is point Q. And this is, I'm going to write AC for average cost. So the in fact, let me just put it up here so it's clear. AC. Again, AC just stands for average cost. Okay. So it's cost divided by quantity, et cetera, et cetera. So the average cost is this. Now we want to find where the average cost is a minimum. So that means, so what does the minimum mean? That means derivatives and stuff. So once we're going to get involved with calculus already, I think I'm going to actually, you know what? That's what I want to do. So let's find AC prime. So AC prime, oops. So AC prime, that's going to equal, well, the derivative of 160 over Q is negative 160 over Q squared. The derivative of 2 just disappears, and the derivative of 0.1 Q is just 0.1. And I'm just going to set this equal to 0. And I'm going to, that gives me it gives me 1 is equal to point 1, I should say, is equal to 160 divided by Q squared. So that means that Q squared is going to equal 160 divided by 0.1, and that equals 1600. The Q is going to equal to the square root of 1600, which is 40. Well, the only thing left to do now is to confirm, the previous problem was just we had upside down parabolas. I knew, I recognize them. This is a little more funky of a term, and of an equation. So what I'm going to do is I'm going to take the second derivative, and because again I could do the first derivative test. The reason I've been continually doing the second derivative test in all these problems is because it just has wound up being easier. Because if the first derivative, you see, that's the first derivative, then so where are we here? So again, this is our so the derivative of negative 160 q squared is going to be positive 320 over q to the third. And so AC double prime of 40, because that's the point with testing. That's just equal to 320 over 40 to the third power. And the truth is, it's a positive number divided by another positive number. So it's definitely greater than 0, which means it's concave up, which means that which means 40 is a minimum. This one minimum, M-N-I-M-U, mum. There you go. Yes, right. Yep. So that is the minimum value. So since the second derivative is positive for all or anytime q is positive, that means that when q equals 40, which is a positive number, that's going to be a local min. So that means that the average cost is minimized when they produce 40 gift baskets. And by the way, you could just plug 40 into the average cost equation, and you're going to get that the average cost winds up being $10 per basket. So it winds up being an average of $10 per basket for 40 baskets. And that, as we say, is that. So that concludes this video. See you next time.